All right, here we're going to work on solving the problems for the Algebra 2 midterm review. So question 1 here, we have to use the graph to identify the intervals on which the function is increasing. So anything that is increasing is going to be going up from left to right. So if we read left to right, this part of the graph continues to go up, and then it stops right here. So that's our vertex, our turning point, so that would change directions there. So in terms of the interval, right, on this side we have negative infinity. On the right side we have positive infinity. So the graph is going up from negative infinity until it gets to this point here, which we drop down to the x-axis, and that would be until negative 1. Parentheses, and then that would be our interval. Question 2, identify the translations of the parent function f of x equals the absolute value of x that give g of x equals x minus 4 absolute value of that plus 5. So this goes back to our rules for y equals a, h, and k. And if you remember, a determines stretches and compressions. H is left, right? This is the short version, and K is up, down. Now, if A happens to be negative, there's also a reflection. That doesn't happen in this case, and A is actually only 1, so we don't have to worry about that. But there's also the potential for a reflection here. So negative A would be a reflection. So for this particular problem, we have a minus 4. So that actually tells us that the graph goes to the right. So this would be a shift right 4 units. And the plus 5 tells us that the graph goes up. So shift up 5 units. Now, if I were to use the calculator and graph this, just quite simply, the absolute value of x looks like this, that blue one. And then if I'm making those changes, so if we put in the absolute value of x minus 4 plus 5, and we graph that, we see that our graph goes to the right and it goes up. So the vertex has been moved. That's good. So 1 and 2 are done. 3, what is the range of the function? So domain would be x values. Range is your, or are your y values. So we look at the lowest point, so we're considering range. So we want to look on the y-axis. So we have our lowest point and our highest point. That would be at 2 and negative 2. So the range in this case, we have closed circles. There should be a closed circle here. But so our range would be from negative 2, low point to high point. So negative 2 to 2. If we were looking at this particular problem from the domain, your domain would be from here to here, right, left and right. So we're looking at x values. But this particular problem, they were just asking about the range. All right, number 4, write a function in standard form that has x-intercepts of 3, 0, and negative 2, 0. So each of these we want to look at as like an x minus value. So we're going to do x minus 3 and x minus negative 2. The real thing you have to be careful, or the thing you have to be careful of here, is your signs. So this negative 2, we want to make sure that we're subtracting negative 2. So that would become x minus 3 times x plus 2. But it does say in standard form. This is not standard form, so we need to distribute this out. So x times x would be x squared. X times 2 knows 2x, negative 3x, and negative 6. Combine any like terms, and then that would be the function in standard form with those intercepts. And if you just want to check things like this, you can always go to your calculator graph. You would type in your x squared minus 1x, or just minus x, minus 6. You're going to hit graph, and then we see that it crosses at negative 2 and positive 3. So this checks out. Number 5, conjugates. We want to change the sign here. So if we have 15 plus 2i, the conjugate would be 15 minus, sorry, 12, that should be 12i. 15 minus 12i. Let me rewrite that so you can see that a bit better. 15 plus 12i. So the sign for the complex part, or the imaginary part there, that's going to change. So in this scenario that you had, let's say 3 minus 5i, the conjugate would be 3 plus 5i. So the I value, the bi part, that is the part that is going to change to the opposite sign. Right, number 6, write the product 5 plus 3i times 5 minus 3i in the form a plus bi. Now notice that we have conjugates here. There's something special about them, or I shouldn't say unique, but there's some special in the case here where the conjugates, when you multiply, all of your I values should eventually disappear. So we use our distributive property, we get negative 9i squared. Now your two middle terms here, when we're dealing with conjugates, should be opposite values, so they would subtract or add out when you take the sum of them. So we'd have 25 minus 9i squared, but we want to remember that I squared is equal to negative 1, so that would become a negative 1 value. So we now have 25 minus 9 times negative 1, so that would become plus 9, and 25 plus 9 is 34. So keep in mind, I squared is equal to negative 1. When you have conjugates, the whole value, or the whole helpful part of using conjugates when you're like rationalizing denominators, is that the I values would go away. Number 7, what is the end behavior of the function x to the third minus 10x squared plus 5? Now, we're focused on this x to the third piece. So this is both positive, so a positive leading coefficient, and an odd degree. So that would tell you, if you remember your rules for these, x to the third looks like this. So your end behavior would be down, up. So this part is down, and this part here going up. Now, these features being positive and an odd degree means that we have this end behavior of down, up. A couple other things you can remember, if you remember what x cubed looks like, which is this one here, or in the fortunate scenario you had a calculator, you could always type in your equation. So x to the third minus 10x squared plus 5. Now the only, or I shouldn't say the only, but one of the drawbacks to the calculator, sometimes the graph is not always visible, exactly like this. So it looks like it goes down, down. Notice that there's a part on the right that's actually going up. So the benefit of unlocking this, or unlocking, I'm reading the, it popped up. Knowing your rules is that if this was the only part of the graph they gave you, we'd get too reliant on that. So if we were to zoom out, we see that on the left side it's going down, but on the right side it actually comes back up. So we have to keep that in mind. And we're talking about infinite symbols. So on the left side it's going down, so that would go towards negative infinity. And on the right side, as x goes to the right, so this is going left, and this is going right. This one's going down, and this one's going up, right? We have our positive infinity, negative, negative. So since it's going up, that would approach positive infinity. So don't be too reliant on the calculator, because if the graph doesn't fit on the screen, we might automatically assume the incorrect answer. All right, what is the sum of 5x to the fourth minus 2x cubed plus 8x to the fifth? So we're adding these. I'm going to write the whole thing out. So I'd have 5x to the fourth minus 2x cubed plus 8x to the fifth plus 3. Now these are not in standard form, so we do want to be mindful of that. So it'll probably look something like this. Since it's addition, we can drop all the parentheses. I have the benefit here of being able to highlight everything in colors. So what I would normally do, on here, I would say, all right, like to the fourth power, I would use colors to match them up. But if you don't have the luxury of colors, I would try to go in order. So I have an 8x to the fifth here. So the highest degree is 8x to the fifth. And I'm going to underline them instead of highlighting them. So 8 and 4 would give us 12x to the fifth. Now I'm going to look for the fourth power. I'll put these as a dotted underline to show that they're different. To the third would be a -2 and a +10, which will be a +8x cubed. And then we have a +3 and a -1, +2. And the benefit of marking them is you make sure you're not missing any terms, which in this case we're not. Combine them, it's in standard form, highest power to lowest power, so everything works out nicely. All right, in this case, we have a subtraction problem. Main thing you want to be careful of here is this subtraction sign is going to apply to everything afterwards. So it has to be distributed to each of these 4 terms in parentheses. So get 10x cubed minus 8x squared plus 4 minus 10x cubed minus 5 squared plus 7x minus 2. So all of our signs would change. We're going to do the same thing that we did in problem 8 now. We're just going to combine like terms. So we have 10 and minus 10. That goes away. Then we have -8x squared and a minus 5x squared. Up a -13x squared. We have a plus 4 minus 2. And notice that there's a 7x here. So I'm just going to drop that down and add the 2. And we have our solution, or our simplified expression. All right, number 10, product, we're multiplying. 8, 9, and 10, the thing you always have to be careful with problems like this is make sure you're doing the correct operation. So 8 was addition or sum, 9 was the difference, we're subtracting them, and number 10 is a product problem, so we need to multiply. You do have the choice of doing the distribution method or distributive method, but for this problem, I'm actually going to use a Punnett square, Punnett rectangle. So I have 2 by 3 terms. So do 8x minus 10, 2x squared plus 6x minus 3, and then just fill in blocks. So 8x times 2x. We'll put 1s here to remind us. 8 times 2 is 16. When we're multiplying terms, we add the exponents. So that would be x cubed. 8 times 6 is 48. Add the exponents. 8 times -3. -10 times 2. -10 times 6. And -10 times -3 would be a +30. Plus sign is not really necessary, but I just want to kind of reinforce the idea that that's going to be positive. So any like terms that we might have, these two wind up being like terms, and these two are like terms. So 48 and a -20 would give us a +28x squared, and -60 and -24 would be -84x plus 30. So notice in numbers 8 and 9, as we added and subtracted terms, the exponents stayed the same. We didn't change anything about those. Number 10, because we were multiplying, for example, like to get this 16x cubed, the exponents were added together. Once we start combining the terms, the exponents don't get changed. So that's for 10. 11, what are the roots of the equation? In this case, one of the most guaranteed ones you can do is usually going to be the quadratic formula. That's pretty much what you're going to want to use on this problem. So we'll go with that. A is 2, B is -14, and C is equal to -13. Now I'm going through these a little bit more quickly than I normally would, but it's just a review. So if you need to watch another problem, rewind the problem, or put it in some slow motion, you'll be able to figure it out. Okay, be careful substituting and make sure you're okay with the negatives and the signs. So we have -b. B is -14. I always recommend using parentheses for anything that you're substituting. I'm going to substitute everything in, and then I'll do some color coding. So our A value was 2. That went here and here. Right, that's A. B was negative 14. B is the one we need to be, I mean, we should be careful of all of them, but B is the one that you need to be most careful of because you have a negative value in the outside and then the B squared, which will make a big difference if you don't use the right sign. Okay. All right, so everything's color coded. So now we'll simplify. It becomes 14 plus or minus 14 squared. I should know this, but I don't want to make a mistake. 196. Negative 4 times 2 times negative 13. So we know that's going to be a positive. And so 4 times 2 times 13, 104. 4 times 2, yes. And then 4 in the denominator, so x equals 14 plus or minus. We're going to add these, not multiply them. 196 plus 104, 300. Especially during an exam, try to use the calculator as infrequently as you need to. But for a problem like this that we know we want to make sure we're getting right, use the calculator just to make sure you're not making silly mistakes or simple mistakes. All right, now a problem like this, that 300, as inconvenient as it is, needs to be broken up. So 300 is equal to 100 times 3. We know, we don't need that x there. We know that the square root of 100 is 10. So the 10 would come out to think here. So the square root of that 100 gives us 10. And in this particular problem, the 14, these three on the outside can all be reduced by a 2. So we're going to reduce those. That would become 7 plus or minus 5 radical 3 over 2. Now, depending on how the questions are phrased, sometimes this is going to be asked to be split up. So you would rewrite this as 7 over 2 plus 5 radical 3 over 2. Let's put this here. And 7 over 2 minus 5 radical 3 over 2. So sometimes they're asked to put them in two different forms. Or sorry, not two different forms. Write the solutions individually. So that plus minus means we should have one positive, one negative. The other thing to be careful of, right? This 2 goes with the 7 and the 5 radical 3. So that's why we have it written twice. Just little details to keep in mind to be careful when you're solving problems like this. Number 12. 12, 13, 14 are factoring problems. Number 12, since there are 4 terms, we want to factor by grouping. So we look at what the first two have in common in terms of a GCF. That would be 2x. Right? 2x goes into 2xy, and 2x goes into 6x. So you'd be left with y minus 3. And then negative 9y and positive 27 have a 9 in common. Now, I know that we have a y minus 3. I want that to match up over here with the same thing. The 27 is positive, and the negative 9y is negative. So that tells me to switch signs, I'll need to factor out a negative 9. Factoring by grouping, you always want these two to match. If they don't match, then factoring by grouping is really not going to work. Since those two match, we take them out. And then we write the leftover pieces there. So this 2x minus 9 would go here. This y minus 3. Technically, it's another GCF step. Comes out there. Nice thing about factoring, you can always multiply back together to make sure you get back to the original problem. I'm not going to do that to save some time. I would always recommend when you factor to check. 13 and 14 are both difference of square problems. We have a subtraction sign in between each of them, and they're both perfect squares. So x to the 6th is x to the third times x to the third, and 25 is 5 times 5. So that would become x to the third plus 5 and x to the third minus 5. Remembering the difference of squares rule will save you a significant amount of time. All right, same thing in the second one. 49x squared is 7x times 7x. 81y squared is 9y times 9y. So quite simply, we get 7x plus 9y times 7x minus 9y. Once again, if you are ever unsure, distribute everything back out and make sure it checks out. All right, 15 and 16, they are asking us to sketch a graph of a polynomial function. So with zeros, -3, 0, and 4. Right. This one's a bit easier because we don't really have to worry about anything other than the zeros. So zeros mean where they cross the x-axis. So we're going to do 1, 2, 3, 4, 1, 2, 3, 4. So -3 would be right here. 0 would be right on the origin, and +4 would be right here. So each of these would become a 0. Do colors real quick. From here, they don't really give you any other information. So it just says a polynomial function with zeros, so there's 3 of them. So it's probably looking at x cubed. We have a couple options here, so I'm just going to draw the most basic one. I'm going to go through, curve back down, and then curve back up. We don't know, so I didn't label the y values specifically for a reason. This graph easily could have also done something like this, where it goes up really high and really low. Like that's an option. It could go up really high and then really low this way. It could have started on the top, gone down, up, and back down. The point is that your end behavior should be opposite, so it should either be down, up, or up to down. So if it went up, down, you would have just started this way. But the actual height of your curves, where your turning points are, you have no information on those. They didn't tell you anything about positive, negative values, so you would just have something similar to that. All right, 16, sketch a graph of a function where y approaches positive infinity. So now this is giving us more information. So we're going to draw our graph. Now remember, infinity would be positive up and right, negative down and left. So same idea. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have zeros at -2, +3, and +5. So let's highlight those so we know what everything is. Now, sketch a graph of a function where y approaches positive infinity as x approaches positive infinity. So what they're saying is that as we go left, the graph is going to go up. Okay, so y approaching positive infinity is going up as the graph x approaches positive infinity. So as you go right, your graph has to go up. So what that tells us is that at the end of the graph, we need to be going in an upwards direction. So it's going to be very similar to number 15. We just have to have this as going up. So now we'll go here, here, and here. In 15, we could have started up and ended down. Well, you get the idea. It wouldn't have really mattered because they didn't give us any other information. In number 16, they tell us very specifically that y approaches positive infinity as x approaches positive infinity. As we go right, we have to go up. So your end behavior on the right side, right here, would go up. All right, let's continue along. Number 17, how many zeros does the function f of x equal -2 times 5x minus 2 times x minus 3 times x plus 8 have? And what are the x-intercepts? All right, your zeros are going to be where these pretty much work out to be. So you have this piece, you have this piece, and you have this piece. each of those has an x value, so each of those has a 0. This negative 2 has no x value, so it does not have 0. If it was negative 2x, there would be an additional 0. So this would be 1, 2, and 3. So how many zeros? There are 3 zeros. And what are the x-intercepts? So the x-intercepts, you would take each piece and set them equal to 0. Let's go back to our highlighting. So this was in blue, red, and green. No, I'm not erasing it. And then solve them. So again, really quickly, plus 2. So 5x equals 2 divided by 5. So x equals 2/5 plus 3 and minus 8. So what are the x-intercepts? This is an x-intercept. This is an x-intercept. And this is an x-intercept. If they're asking for the actual coordinates, remember your y value would be 0. So we have 3, 0, and negative 8, 0. Going back to our calculator, we could, somewhat inconveniently, but we can put this whole thing in. It'll take a little bit of time, but if you just want to make sure what the graph looks like, you could type this in and an x plus 8. Just always double check that you typed it in correctly. And if we hit graph, we see that we have x-intercepts at negative 8, 2/5. So the 2/5 one we can't really, I mean, we know it's there, but we're close to the origin. We don't know it's 2/5 just by looking at the graph, so we would have to figure that out. And then the positive 3 one, so everything checks out. All right, so that's 17. All right, 18, average rate of change. We are using the slope formula. That's going to be y2 minus y1 over x2 minus x1. That's not an x. It doesn't really matter which one you choose as x1 and which one's x2, but I'm going to say that y2 will be there. y1 would be the other y value. And then your x's, oops, I did it again. Your x's have to match up with your y. So x2 has to go with y2. And x1, again, x1 has to go with y1. So just make sure those are matched up. Other than that, these should be pretty easy problems. We substitute them in. So negative 5. Just use parentheses out of habit. So negative 3 was here. Red, blue, and green. Right, 15 minus 0, that's easy. 15. Negative 5 minus negative 3. Be very careful. That's negative 5 plus 3. So that gives you a negative 2. You can rewrite this as negative 15 over 2, or because if you type these in, it comes out as a non-rounded decimal. So you could say negative 7.5. In general, when you're talking slope, you usually want your rise over run. So I would leave it in this form. The negative 7.5 is not wrong, but you really would prefer being here. The recommended option. Okay. All right, what is the average rate of change of the function? Number 19. So 19 is the same as 18, but we do not have the coordinate points yet. So the interval is 3, 6. These are both x values. We don't want to confuse that with a coordinate point. So what we need to do is we need to take f of 3 and f of 6 because we need to know what the y value is. So we're going to look at this equation or this function and then plug in the 3 and plug in the 6. So this would be 3 squared plus 8 times 3 plus 2. And this would be 6 squared plus 8 times 6 plus 2. So f of 3 would be 9 plus 24 plus 2. 9 and 24 is 33, so this comes out to be 35. And f of 6 would be 36 plus 48 plus 2. So f of 6 would be 50 plus, that would be 96. So the coordinates are 3, 35, and 6, 96. Now that's what gets substituted into your y2 minus y1 over x2 minus x1 formula. And going back to the calculator, we have the option, we can do wrong button. We can type in our function of x squared plus 8x plus 2. We can go to our table and notice we're plugging in 3 and 6. So at 3, it's 35, so we did that math right. And at 6, what did I do? Oh, that should be an 86. I'm trying to do these too quickly. That should be 86. Apologize for that. So 6 and 86. All right, so y2 minus y1. Again, doesn't really matter what you pick as your y2. I'll start with the one that's actually listed second. y1. Your x2 has to go with y2, so coordinate those. And x1 has to go with y1, coordinate those. So y2, 86 minus 35 over 6 minus 3. Let's click this out. Let's not make another algebra mistake. So 86 minus 35 is 51. 6 minus 3 is 3. These don't look divisible, but they are. So if you don't believe me, 51 divided by 3 is 17. So your average rate of change will be 17 or 17 over 1, however you want to look at that. All right, I'm going to stop this video at 19. I will pick this up. Or actually, you know what? No, we're just going to continue. I'll get everything done in one shot. Why not? All right, 20. For what values x is the function y equals x squared minus 4 always negative? This negative 4 tells us that it shifts down. So if you're doing this by hand, x squared is right here. Right? We have this curve here. And if you had a table, right, you'd have like, you could plug numbers in, you can figure out what's going on. But this shift down tells us that the function is going to move down 4 units. So it's going to be here. So in terms of negative, that graph would be negative anywhere below the x-axis. So these values. So we need to determine what this x-intercept is on the left and on the right. So we'll do our x squared minus 4. We'll graph this. We need a couple of points. Don't be too picky about them, but the important ones are the zeros. So you can see on this screen, the handheld calculators don't always have the values, the numbers, but you can see it crosses at -2 and +2. And then it goes down to -4. Now, if you didn't have the values on the screen here, you would go to your table and you would just pick coordinate points, pick enough points where you could graph this. Okay, -2, 0, and 2, 0. Your graph looks something like this. Again, negative is below the x-axis. So from this point to this point. So what values of x? Those values would be from -2 to +2. And if you look at your table on the calculator, from -2, now actually -2 is at 0, which is why we're using parentheses and not a bracket. But -1, 0, 1, they're all negative. All the decimal values between those would also be negative. And at +2, it's 0, which is not negative. But again, that's why we are using a parenthesis. All right, 21, sketch a graph of the function. So again, x squared we know would look like this here, based on our A, H, and K rules. The +2, this +2, and this +5 tells us the graph goes left 2 units and right. I'm sorry, not right. Can't go left and right. And the +5 is up 5 units. So from here, this graph is going to go left. Let me change colors here. This graph is going to go left and up. So just take your vertex, move it left 2 and up 5, and then you can draw a sketch of what that would look like. I'm going to draw a cleaner version. So if we were here, we move 5 in each direction. 1, 2, 3, 4, 5. My vertex 1, 2, 3, 5. 1, 2, 3. So vertex goes left 2, up 5. So the vertex is going to be up here, and then we have our sketch this way. And if you have access to the calculator, you can always use that to help you out a bit. We have x plus 2 in parentheses. Make sure you're putting the right notation. Plus 5. If we look at the graph, we notice it goes left and up. So that gives us our sketch. All right, 22. What are the x-intercepts of y equals x squared? We want to find the factor form of this. So factors of 20 that have a sum or a product of -9. So 1 and 20, 2 and 10, 4 and 5 are the options we can work with. Now, notice that none of these actually give us the -9 value we're looking for. 4 and 5 gives us a +9. Plus 20 or +20 can be found by doing positive times positive, but we also can multiply negative by negative to get a positive value. So these would all flip to negatives. This is what we're looking for. So we want 0 equals x minus 4 times x minus 5. Zero product property tells us we can set each of those pieces equal to 0, which is why we set this equal to 0 here. Solve. So x is equal to 4 and x is equal to 5. So if we were to graph this, you would have intercepts at 4 and 5. The graph looks something like that. Again, very rough sketch, but that's the quick idea. So again, if you want to say your actual coordinate points would be 4, 0 and 5, 0. Sometimes they'll ask for the coordinate point. Sometimes you just need to label them as an x-intercept. Number 23, what are the zeros and vertex of the function? So the zeros we're going to find the same way. Your zeros are your x-intercepts. So we want factors of -12 that have a sum of -4. So 1 and 12, 2 and 6, 3 and 4. Now, a -12 means one of these has to be negative, so we can also write them in the opposite form. I would not recommend writing all of them out. If you can save yourself the time, do so. We want a -4, just for simplicity. 2 and -6 are going to give us the -4. So what are the zeros? We'll finish out this problem as x plus 2, x minus 6. So 0 equals x plus 2, 0 equals x minus 6, minus 2. X is -2 and plus 6. X equals a +6. So the zeros are -2 and 6, however you want to phrase that. Notice in one of the other problems I put zeros with OES. It's kind of up to you how you want to write that. But these two are your zeros or zeros. And in terms of finding the vertex, so the vertex is going to be equal to x equals -b over 2a. And then once we have the x value, we have to plug it in to find the y value. So for this particular problem, a equals 1, b equals -4. I know this is a little messy, but just, I guess, deal with it. E is -4, so that's going to go there. The c value doesn't really matter for us in this problem. The c value is your y-intercept, so if you were to graph this, you would see that, but we're not asked about that. So let's mess it over here. So x is going to be equal to -4 over 2 times 1, which is 4 over 2, which is 2. So y is going to be equal to the 2 value plugged in to the equation. Let's use green. So this is our x value. That's going to get plugged in here and here into the original. So y would be equal to 4 minus 8 minus 12. Negative 4 minus 12, negative 16. So the vertex has an x value of 2 and a y value of negative 16. All right. All that can be checked on the calculator. So if we go to our function of x squared minus 4x minus 12, we look at our graph, we see that it crosses at negative 2 and 6, so the zeros check out. Now we can't see on the current screen where the vertex is, but if I zoom out enough, they're not going to let me go further because I probably have to pay for it. But you're going to see it's lower. The way we could kind of confirm this is look at the table, and the negative 2 value, positive 2 value, is negative 16. Based on the table, that is the lowest point, so that's a good chance. There's always the risk that it's a decimal, so in this problem it's not going to be, but it could potentially be. So again, not too reliant on the calculator. Make sure you are able to do problems like this by hand. All right, that's 23. Let's move on to 24. Come up on 40 minutes on this video. Hopefully it all saves properly and I don't have to redo this. All right, solution to the system of equations. Here we have y isolated, so that tells me that I'm going to use substitution. So y being equal to 2x plus 4 means I can plug a y in there. So 2x plus 4 times 2x plus 4 happen to be the same numbers. That's just a coincidence. It won't always be the case. So we have 2x plus 8x plus 16, 10x negative 10 divided by 10 x equals negative 1. All right, we need the solution to the system, so we need a y value. So I'm going to go back to the y equals 2x plus 4. Substitute in your x value and simplify. So x came out to be negative 1, so that's going to go here. And then y turned out to be 2. So our solution, let me not put it there, we need space for the next problem. Our solution is negative 1, 2. Highlight that and that. The calculator work. So the calculator you can use if y is isolated. So in case of 2x plus 4, that one would be easy to enter. But the 2x plus 4y equals 6 is not isolated for y. So we could not enter that in the calculator in the form that it's in. You could take the 2x plus 4 equals 6 for y and get y by itself. Right, so if I were to do this and then divide by 4, I want to be careful with our signs. So this would be 3 over 2 minus 2x. So I could potentially type this in as 3 divided by 2 minus 2x. And I could look at the graph and see where they intersect. It looks like they intersect at negative 1, 2. Oh, no, we did something wrong here. 2 times negative 2 plus 4. So these cross at, what do we do here? Where are they the same? Negative 1. Oh, did something wrong here. 6 over 4 would be 3 over 2. What did I do wrong? Y equals 2x plus 4. 2x plus 4, 8x, 16 equals 6. 2x and 8x is 10x, so that looks like it checks out as negative 1. No. And y equals 2x plus 4, plugged in the negative 1. I think it's 2 plus 4 is 2. So what's going on here? What did I type in wrong? minus 2x plus 4, and 3 over 2. Oh, because this here is not negative 2x. Again, trying to rush through these. Don't rush on the exam. This was 1/2 x. So now, if we go back and fix that, this should have been 1 divided by 2 with an x. And now if we graph it, now we cross at -2. So if I go to my table, at -1, the values are the same, so everything checks out. 43 minutes in and my mind's going to mush. All right, so 24 is good. All right, 25, what is the solution? Now, neither one of these are isolated, so substitution is still an option. You could isolate this x. It would probably be pretty easy to do that, but I generally prefer elimination if they're in this form. So they don't match up. I'm going to multiply the top one by 2. And the bottom one, I guess technically you're multiplying by 1. In this problem, it's convenient. You'll see it again in the next one in a little more detail. But I'm choosing the coefficient that's in front of each of these values. So that's where the 1 and the 2 comes from. So this becomes 2x plus 10y equals -2. Make sure you distribute to the entire process. And times 1 doesn't change anything. So this would all stay the same. These are the same signs, so we're going to subtract. 2x minus 2x is 0. 10 minus 10 is 0. And the -2 minus 3 is going to be -5. Now 0 equals -5, which makes no sense. So no sense means no solution. And you could graph these. I'm not going to go through that whole process again, just for the sake of time. But notice that everything cancels out in a way. The x's and y's both cancel out. If there's no solution, that means that your equations are going to be parallel to one another. They never cross, they never intersect. All right, now 26. Again, these don't match up as the same. These do not match up as the same. So I'm going to multiply the top by the -3. You can use, the sign's not important, so I'm using the exact same just for the sake of demonstration. But these values are being picked from here. All right, so now we multiply everything out. So we get -12x minus 15y equals -36. -12x plus 8y equals 1428.56. -12 and -12 are the same, so we subtract. Now, if you accidentally put a plus sign here, -12 plus -12 is -24. That doesn't go away. We're using elimination. I didn't write that over here. So we want to eliminate. If we don't eliminate anything, we're not using elimination. So -12 minus -12, that's 0. If you don't trust it, type it in the calculator, you get 0. -15 minus 8, so that's -23y. Again, if you don't trust yourself, type it in the calculator, get your value. If you don't trust yourself again, do the -36 minus 56, get -92. Divide both sides. And y would be equal to, should be 4, but we'll just make sure. Divided by -23. And we get 4. So the y value can go into any of the original equations. I'm just going to take the first one listed, substitute the y value in, and then solve for x. What color? Make that green. 4x plus 20 minus 20, 4x, make 8, and then divide by 4. So x equals -2. So our solution will be -2. Y was in green, and let's make x pink. All right, there's our solution up to 26. So substitution, elimination, either method is a viable option in any scenario. You can always use them, but usually substitution should be when a single variable is already isolated. And then if x and y are on the same side, elimination is generally the better method. Just know that sometimes you'll have to multiply the equations so that they balance out and something cancels. Something can be eliminated. All right, 27. Using the function 4x squared plus 6x equals 3, what value would represent n when using the quadratic formula? All right, so the quadratic formula is negative b plus or minus b squared minus 4ac over 2a. We are concerned with this n piece right here. So this is what we want to focus on. For our problem, a is 4, b is 6, c is, oh, this 3 should be moved over. So let's do that. So we have 4. It won't matter in this problem, but it's always good practice. Equals 3. So we want to subtract this 3. When you're using the quadratic formula, everything has to be on the same side. So now a is 4, b is 6, and c is negative 3. What we want to be aware of is that the negative b value is what turned into n. So if I have this negative b, b is 6, so that's my n value. So n is negative 6. Right. This is kind of a tricky question in the sense that they're asking about n, which is in the place of a b, but we can't forget about this negative here. Right. So they're not asking what is b, they're asking what value would be in place of n. Be careful with this. This b is 6. So you can plug that in here. The 6 and the b look the same. Let's make that more of a 6. It's a little better. And you can set it up in this form, right? That n value has to be equal to negative b. So take your b value, plug it in, make sure it all checks out. 27 is, again, not a difficult question, but you just have to be careful answering what they're actually asking. All right, 28, object is launched from the building. The height of the object in time seconds is given by the function. When will the object hit the ground? All right, so h of t represents our height. This shouldn't say h of, this should either be an x or these should be t's, but either way, it's going to work out the same. So it's just a simple typo there. So when the object hits the ground, that means our height equals 0. So we want this to be equal to 0. These numbers are quite large. Like, I don't want to do the AC method and do negative 10 times 240 and then find factors of negative 2400 that up to 50. So if you notice, a negative 10 can actually be taken out of all of these, and we get a much easier problem to work with. So this would be our GCF. Now we can do the factor sum method. So we want factors of negative 24 that have a sum of negative 5. Again, just for the sake of time, I'm just going to write the answers. So this would become x plus 3 and x minus 8. The negative 10 isn't going to be equal to 0 because there's no x value. So the zero product property tells us that x plus 3 equals 0 and x minus 8 equals 0. Solve each of these. Oops. So we have an x of negative 3 and an x of 8. The question is, when will the object hit the ground? X being the when. This one here is negative 3 seconds. That does not make sense. All right, we can't have negative 3 seconds. So any negative x value we can rule out. That doesn't work. So this would be our solution. So when will the object hit the ground? We could say after 8 seconds or at 8 seconds. There we go. So this will give you two solutions, but only one of them is realistic in the real life scenario. All right, 28. Last two problems. What are the solutions to the equation? All right, this is just another factoring problem. The thing to recognize here is that we need to set the problem equal to 0. Now we can simply find factors of 24 that have a sum of 10. Yep. For the sake of time, pretend I wrote them all, or you know what the answer is. It's going to be 4 and 6. So x plus 4 and x plus 6, 0 product property, subtract. And we have our solutions. Again, this is one that coming up on 53, 54, 55 minutes. So I'm just going to say that these are answers. You could type this portion in the calculator and confirm that your answers check out. All right, number 30, what is the domain of the function? Now, this is kind of, in my mind, a slightly silly question, but the domain are the x values. So they're asking what x values can we use? The plus 3 tells us this goes left and this goes down. That doesn't really mean much in this problem, because if you have your x squared function that looks like this, oh, that's terrible. That looks like this. If it goes left and down, it's going to end up, so left 3 and down 2, so somewhere about here. It's going to go something like that. It still keeps going left, it still keeps going right. So it's always going to go left. It's always going to go right. So what is the domain? The domain is all real numbers. So depending on how you're phrasing this, you could say negative infinity to positive infinity. This could be all real numbers. Anything works for x. There's no limits to what you could use in the domain. Now, for this particular problem, had they asked about the range, this bottom value is a -2. So it would go from -2 up to infinity. They're not asking about the range, but if they were, that would actually have a change. So the range would change from the original to the second one with the shifts. The domain doesn't get affected because the graphic still keeps going left and right to negative infinity and positive infinity. All right, that's the entire review. Hopefully everything made sense. If there's any questions, obviously reach out and I can help you out with them. I'm going to upload this as a video. I'm going to try and put like kind of bookmarks on each number so that you can skip to whatever one you want. But they are in order, so shouldn't be too much of an issue. I'm sure my writing was probably not that it's ever neat, but probably much neater at the beginning and got a little hectic and chaotic towards the end. All right, well, we're done. Have a great day, study, review, and if you have questions, reach out. And good luck on the exam.